Okay, welcome to part 2 of our video tutorial. We're looking at the 2009 paper of Aqueous Chemistry, level 3, and we're up to this part right here. So get rid of pause. Gone. Okay, we have got a solution prepared by dissolving sodium methanoate, which has a pH of this. In other words, it tells us it is a base. Now, normally we'll be writing Ka equals blah blah blah, but in this situation here, we're probably going to be looking at the Kb because it is in fact a basic solution. Okay, what is the Kb? Well, just like up above when we did the up above. No, we haven't. Never mind. We have this situation here occurring. Oops, not CH3. That was the ethanoic. We want methanoic, which is HCOO 1 minus. That's the methanoate there. We ignore the sodium. The sodium is a spectator. It just sits there not doing anything. Plus H2O turns into equilibrium arrow. Oops, not C. Start it again. HCOOH. It picked up the H and leaving OH 1 minus behind. So in other words, it's made a base. Excellent. So we've got to this situation here where the H2O has lost its H plus because this part here has accepted it as a base. Cool. Which means we have got a situation where we can go Kb equals the products HCOOH and OH 1 minus on top, and underneath we have got the HCOO 1 minus, and of course we ignore the water again. Right, now we know already the Ka value, okay, because we know the pKa. Okay, what was that again? I missed it. 3.7. Okay, so pKa equals 3.74. Is that right? Yep. Cool. And therefore the Ka must equal, okay, get my calculator out. I'm doing the 10 to the x button, which is the inverse log button, of minus 3.74 equals 1.82 round off times 10 to the negative 1, 2, 3, 4. Cool. So that's the Ka of this thing here. Right. One thing I must remember also is that Ka times the Kb is equal to the Kw. Or I could say the pKa plus the pKb is equal to 14, which is the pKw. Cool. Right. So I know this. Okay, I also sort of know this guy here because I know the pH, therefore I can work out what the H plus concentration is, therefore I can work out what the H plus concentration is. And if I know this, which is X, I also know this, which is also exactly the same number in this situation. Therefore I know everything apart from that bottom row right there. Whew. Okay. So let's go through. I know that. Tick. But I've got to go through and calculate this one right here. If the pH is equal to 8.65, then the H plus, or actually let's do it even easier. Oops. Did it again. Even easier is, I can know that the pOH is equal to 14 minus 8.65 equals, okay, 3.5. Okay, let's put it in properly. 5.35, because the pH plus the pOH equals 14, which means that the H plus, sorry, the OH minus concentration is equal to 10 to the x did it wrong. 10 to the x of minus 5.35. Oh, that wasn't the plus. Delete. 0.35 equals. Okay, so the OH concentration minus is equal to 4.466 times 10 to the minus 1, 2, 3, 4, 5, 6. Cool. Now, we're well along the way. I'm hoping this is all correct because I've just gone through it real fast. I'm just double checking the answers to the side. Yes, it's all excellent so far. So, what do we need now? Actually, I don't have the KB yet. I've still got to calculate that. But now I know what x is equal to. What on earth am I doing down there? Minus 6. That's better. Right. So I now have that on there sorted out. Tick. And also that on there sorted out too. Tick. Because they're both exactly the same answer. KB. I've already told you that the Ka and the Kb, when you multiply them together, equals Kw. I know the pKa of this, which is plus pKb equals 14. So I can do the exact same thing as before. I know that the pKa is 3.74. Therefore, the pKb must equal 14 minus 3.74 equals 10.26, which means that the Kb is equal to 1 times 10 to the negative 10.26. Okay. Shift log, which is the x10 button. What about to the negative 10.26 equals 5.495 times 10 to the minus 11. Cool. So now what do? This number here goes into there. Okay. This number here goes into there, and then I've got to rearrange the entire equation to make that the subject of the equation. Whew. Okay, when I end up doing that, this is like a I'll just go through and rearrange it. The concentration of C. I shouldn't be doing this tutorial so soon after lunch. My brain is completely soggy. Equals the OH minus concentration squared, because remember it's these same numbers, x and x, which is the same as that squared, over the Kb, which equals 4.466 times 10 to the negative 6 brackets squared over 5.495 times 10 to the minus 11. And when I plug that entire thing there into a calculator, in theory, just double checking I've got the answers correct here so far. Yep, that's good. And that's good too. And yes, when I plug it all into the calculator, I end up getting 0.363 that is actually 363 moles per litre, and that's the concentration of this guy right here. Okay, huge. You're probably thinking that has got to be worth excellence. Well, you are so right. Okay, if you got one step of the calculations correct, then you still get marks. Okay, with minor errors, you still can get merit. but with everything sensibly rounded off and units are required, notice that, units are required, only when the units are there do you end up getting excellence. Wouldn't it be sad to do the entire thing, get it absolutely perfect, but miss out on excellence? Yes, it would be. Okay, moving on. Question 2. The addition of chloride ions into a solution of silver nitrate forms a white precipitate of silver chloride. This is a KS one, so we're now talking about solubility. We've moved away from acids, and here we go. Calculate the concentration in moles per litre of silver ions in a saturated solution of silver chloride at 25 degrees Celsius. Okay, cool. So we need to know the maximum silver ion concentration available. We know, once again, that the Ks is equal to, notice once again, I am going through and writing out the expression. These expressions are vitally important because we can then substitute things into them. Right, this and this are going to be the same number because when they split up, it makes one lot of that and one lot of this one. Okay, so they're going to be the same number. Now, this Ks here, I can substitute into it. So in other words, now I'm not going to call it X in this case here. I'm going to go through and call it something very different. I'm going to call it S. Why S? Because that is a fancy symbol for the solubility. So in other words, the Ks equals the solubility squared. That's the maximum solubility of these two things, which of course are exactly the same number. Right. Calculate the concentration in moles per litre of the silver ions, blah blah blah. So in other words, I can go solubility equals the square root of the Ks. Remember in the previous exercise, we got rid of the S squared by square rooting both sides. By square root this side here, square root that side there, that gets rid of the S squared and turns it just into S. Right, so plugging it into my calculator, 1.56 to the exponent 10 negative, and then square root it. Ooh, okay, wrong order. It equals 1.2489, of course terribly rounded, times 10 to the minus 1, 2, 3, 4, 5. I've got to change the setting on my calculator so it just does that. Moles per litre. Cool. So there we go. That is the concentration of Ag plus at maximum solubility. Of course, it's not just the Ag plus concentration, it's also the Cl minus concentration. Right, let's go further down there. Solid sodium chloride is added to 5 litres of that much silver nitrate solution. Calculate the minimum mass of sodium chloride that would need to produce a saturated solution of AgCl. We know that a saturated solution is when that Ks value is reached by getting the Ag plus and the Cl minus multiplied together, correct? But this time here we're actually adding extra stuff, so we're not talking about the Ks anymore, we are talking about the ionic product. Now, another 15 minutes is whirred by. We're going to pause it right here and come back to this question here shortly.